Hi folks, welcome back. If I were to ask you what is the most used programming language in the world, you'd probably be surprised if I told you the answer was Microsoft Excel, because it is spreadsheets that allow non-technical end users to programmatically analyze and manipulate their data, their own data. And I don't think we've quite yet had the spreadsheet-like abstraction for AI and LLMs. Of course, everybody uses the chat modality, but I don't think that is quite it. And this paper by Eric Meyer is proposing something like that, a lightweight programming abstraction on top of the natural language that we use to prompt LLMs. Eric Meyer is a well-known researcher. He has a programming languages background. He's worked on many programming languages like C Sharp and so on. So it makes sense that he's coming at this from programming languages and compilers mindset. But let's go through the paper and see what he's proposing. So he's proposing a new programming language called Universalis, designed for knowledge workers to read and for what he's calling a neural computer to execute. This neural computer is an LLM. But that sounds pretty abstract. So let's look at an example of what that would look like. So here is a question. This is kind of a typical GSM 8K kind of a query where it is about buying something at a given price and calculating the profit or loss. The important thing here is this notation between the square brackets, the price at which apples were bought and the price at which they were sold and what the profit percentage is. So that is what the user inputs, and the generated Universalis implementation of it is essentially a chain of thought solution that does reasoning and planning over this query to compute what the profit percentage was. Now, if you've looked at all these benchmarks, if you're familiar with prompting, you know what chain of thought is, this will look pretty familiar. This pattern of having a query like this and a chain of thought solution like this is pretty well understood. The new thing is this data binding and variables inside these square brackets. And this is the sort of lightweight programming and data manipulation abstraction that the author is building with Universalis. So of course, when you actually run this program, you will have to input the values for those variables. You have to bind them to some concrete values in order to get the required output. And this again is a very spreadsheet-like environment. Note that in most spreadsheets, you can toggle between these two modes where you actually see the calculated numbers or you see the underlying formulae. And this looks really simple and natural because it is. It's basically literate Excel spreadsheet formulas. These expressions in square brackets are called hedges, and these hedges are surrounded by natural language descriptions or explanations. So there's not much of a syntax really. It's not a programming language in the traditional sense of the word, like Python or C++. It is still natural language, mostly natural language. Under the covers, the implementation is based on Prolog, and the bindings inside the hedges are logic predicates. And once you have this basic natural language with hedges idea set up, you can then start building a few more constructs on top of that, constructs that you might be familiar with from traditional programming languages. So for example, you could specify preconditions and postconditions. Preconditions are things that must be true for the computation to make sense before you even start the computation. So for example, with that apple buying example, one of the preconditions would be that the price at which you bought those apples must be positive, or the price at which you're selling it must be positive. Again, if you've written a lot of code, you know about this mode of thinking where when you write a function, say a sorting function, you have some preconditions and postconditions, things that you want to be true before you call sort, and things that you want to be true after sorting is finished. And so at the end of the computation, you want these post conditions to be true. For example, the profit percentage should be non-negative. And note that all this is still just expressed in natural language. And you can keep building up your tower of abstractions. For example, traditional programming languages have conditionals. You can express conditionals in Universalis, again, just in natural language. It's just natural language. For example, I have Bitcoin, and depending on how much I have, I want to buy some other stock. And that condition is simply expressed in natural language. If that is enough to buy Microsoft, do that. Otherwise, keep the Bitcoin. And it's interesting to see the typical chain of thought solution to it. First, you get today's date, then find the current price of Microsoft stock. There's a little tool call embedded in here. There's another tool call to find the price of Bitcoin. And then there's all the computation for calculating the value of your holding and whether it's enough to buy Microsoft. What's the next thing you want to build after conditionals? It is for loops or while loops. And there's a very natural way of doing loops by applying a computation to a collection of data rather than a single element. This should be pretty familiar from spreadsheets, because if you want to apply the same formula to an entire column of numbers, you'll typically just put the formula in the first row next to your first number, and then you'll just drag it down to apply the same formula to the rest of that column. So this is just like spilled behavior in spreadsheets. One very useful primitive is pattern matching, especially when you're dealing with a lot of structured data like in JSON. This is straight out of languages like Haskell and OCaml, where you can do pattern matching on deep nested data structures like trees. But for example, if you have a big JSON structure like this, and you're only interested in a couple of fields out of that, Universalis supports this kind of a syntax to just pick out the fields you care about and bind them to these variables. I love this note the author has over here. As a language designer, it's always tempting to add more features. Think C++. And in Universalis, the author is trying to keep the language minimal, focusing on sequential composition, implicit looping, and so on. And it looks like he is indeed staying true to it, because if you look at all the examples in this paper, they are very easy to read because, well, they're just natural language. And the variable binding concept should be familiar and natural to everyone. If you've worked with writing formulas in a spreadsheet, this is a very natural way of expressing computation over data. I found this comparison with workflow tools really interesting. Things like UiPath, and I think more recent tools like N8N also fall into this category. They mostly use sequential composition. They have some limited control flow. So they have the notion of an if node in the flowchart. But as the author correctly points out, the problem with all those workflow tools is they don't have a good abstraction to manipulate the data that is flowing between those workflow nodes. And that is exactly what he's proposing in Universalis, this neat syntax of hedges. And this might seem counterintuitive because this is just natural language, but the implementation is a typical compiler stack where you have to lex and parse the program text. You have an abstract syntax tree. You do some type checking and semantic analysis on that abstract syntax tree, and you bring it down into an intermediate representation. This is a very typical compiler pipeline, but the internal representation doesn't look anything like what a typical compiler has, because again, it's all based on natural language. So, for example, the internal representation after the compiler has parsed it looks something like this, where you have a comment and then you have an expression, but the expression is mostly just natural code. So to sum up, the author here is describing a language, Universalis, to instruct LLMs purely via natural language with some very simple syntax for binding variables and then manipulating data using those variables. It lets you do loops and pattern matching purely with natural language, and it's basically using the LLM as its quote unquote virtual machine, as its execution layer. So I really like this direction because I do feel we need a little bit of structure on top of the basic NatLang that LLMs can handle. And this seems like just the right level of abstraction without it getting too complicated, without it going away from natural language and into a full-fledged programming language with its own full-fledged syntax. So this is really cool. I really want to see more along these lines. I don't think this is open sourced yet or available for people to try out. I really look forward to that because I really want to see what more complex workflows look like, not just GSM 8K kind of things, but much longer workflows. Think of something you'd have as multiple tabs in a spreadsheet, a very complicated spreadsheet. But yeah, this is really cool and a great direction to be building workflows and apps on top of LLMs. All right, thanks.